All right, so this one is like actually crazy, okay? Today we're going to talk about copy fail. I've heard some people refer to it as copy.fail, though I think that's just the website for it. We're going to be talking about copy fail CVE 2026-31431. This is a pretty big Linux vulnerability. It allows you in just a couple lines of Python is the example, but technically you can do this in any code. Just a couple lines of Python on a user account on Linux, I can suddenly get a root shell in like less than a second. So it's a pretty big deal, and it affects any Linux kernels, I believe, after 2017, so it's been around for a while. I know that certain distributions of Linux are already protected against it because of possibly SC Linux rules or AppArmor stuff. I don't know the specifics there. I just know that today I'm going to show you how we can test for it. I'm actually going to run it on my own machines. We're going to hack my own machines today. It's going to be a ton of fun, and we're going to test for it, and we're going to protect against it. Now, before we jump into this, I just want to say that I have tested for it myself on a couple different Linux machines I have, like for instance that Raspberry Pi back there on that mirror is running Linux. I tested that one, and I tested my public facing servers, like my web server. They're both fine. They're protected against it. I still did an upgrade just because, hey, why not? Let's run the latest bits, but they're protected against it, so that's pretty good. But I do have some virtual machines that are vulnerable to this. So I think it'd be fun today to go through in a video and fix them there. I was just going to fix them on my own, and then I was like, wait, people might be interested in this to see how I, as like a sysadmin or someone who has to manage a bunch of different Linux virtual machines, deal with this. Also, side note, if you've recently watched my videos, you know that I recently quit my job as of last week, and I was working as like a sysadmin kind of role. So I am so thankful for that, because I would probably have to be dealing with this and figuring out how to roll up operating system upgrades or patching the kernel or whatever. That may fall onto me. And I'm just so glad that that's not the case anymore. So shout outs to everyone out there, all my brothers and sisters out there that are doing the sysadmin role and have to do all the Linux upgrading and patching to make their system secure and not vulnerable for this. I feel you. I've been there in the past when there have been other vulnerabilities. So good luck out there. But I figured today I can show you how I would go about testing for this myself and how we can fix it. Last thing I want to say, this is not going to be a technical deep dive. I'll explain some of the specifics of it, but I'm not going to deep dive exactly how this works or why this works, because let me tell you, even though it's a couple lines of Python, it's very complicated actually. There's a lot that's going on under the hood. So I'm going to do the thing that good YouTubers don't do, and I'm going to direct you to someone else's video right at the beginning of this video. This is probably going to take my attention, but I don't really care. Go check out this video by Low Level. He does a great job explaining this. He dives into the specifics. If you want to understand the nitty gritty behind the scenes, like Linux kernel stuff that's going on there, check that out. For this video, I'm going to show you how to, one, hack my own machine, and two, how to protect ourselves against it. So let's jump in. All right, so here's the website for it. The domain is just copy.fail. You can go here and it explains all about it. 732 byte Python script. So it's pretty awesome how it works. If we scroll down, you can see examples of it working. We'll actually get the source code they link to it, which is super nice, so we can do it ourselves. Copyfail exp.py, so it links here. We can also curl it from this remote server. I'll show that example. We'll curl it and we'll run through the source code ourselves without actually curl pipe Python, but we'll be good about it, and I'll show how to actually look at this stuff. All right, so here we go. We're logged into my desktop. Let's go ahead and log into our Linux virtual machine that we have here. Its name is Void. Here's some information about it. You can actually see like the version of the kernel we're running and everything. So first things first is we have to pull that code. I've copied it from the website, and here's what it looks like. Curl that thing, and then we pipe it to Python 3. Instead of that, let's go ahead and write this to a file. Let's just call that copyfail.py. There we go. So now we have a file in my home directory called copyfail. Before we run it, let's go ahead and look at it and make sure everything just seems sane here. All right, so here's the source code. It's a little minified. It's super ugly to read. So again, go check out the low level video if you want to learn more about how it works. The basics of it is that we create a new socket, and the socket type is not like address family Unix, like AF underbar Unix or AF underbar, what is it, like TCP IP or whatever those address families are. This is a special address family for Linux called AF underbar alg, which is like crypto algorithms in the kernel that you can communicate with over the socket. I've never used this interface myself. I'm sure I've used software that's used it. So that's how it's working under the hood. Yeah, so basically we create our socket here, and we have type AF underbar alg, and then we have our send message, and then our splice. So it's a combination of splice, the socket call with AF underbar alg, and this thing, this authn CS. I don't know exactly how this specifically works, but like I said, I'm not really a crypto guy. I'm not like a security expert here. I just know how to run commands on my computer, and we're going to break them down, and we're going to show how to manage this across multiple computers. But here's the actual like crux of it. We open user bin su. The reason we do this is because su is typically set UID. That means it will run as technically the owner of the file. It'll be owned by root. So it'll run as root even when it's ran as not root. So like if I'm user Dave, I run SU, it's going to run as root. Now it should check my privileges and make sure it doesn't run unless I'm authenticated. We just override that with this basically malicious payload. So we're taking this gets converted into the actual bytes, and we just put this over a part of the SU binary that is loaded into the kernel's memory. A little bit confusing. The kernel caches this stuff in the memory. We're going to mess with that page of memory. So then when we run SU, the kernel's going to look at that modified page and it's going to run a version of SU that's just going to work for us. It's going to make a root shell for us. So the final thing we do is we just run SU. So we modify SU here and then we just run SU here. And this is what gives us the root shell. We can actually go ahead and get rid of this. So we just get rid of that line here. So we're not actually going to start the shell, and I'll show you what this looks like on this machine. So if we do Python 3 copy fail.py, there we go. Now it is patched SU. That's it. So if I run SU, there we go. I have a root shell. Like that's it. Like I mean it. Like that is it. I could touch something in the root directory like, haha. And now I have a directory in the root directory, or sorry, I have a file in the root directory called haha. So like, I have root privileges. It's not great. Oh, it's no tab complete, of course. Not fantastic, but like, look how simple it is. Here's the beautiful thing. Because we already ran it, I can just run SU again, and it's patched. It's just sitting there in memory. I could exit out of SSH. I could SSH back into the machine, and I could run SU, and it is still there. Do you see how gnarly this is? Do you see how wild this is? This is crazy. Also, I just realized I should have done this at the beginning of the video. Let me go ahead and close out of this. I'm going to go out of Void, so I'm back on my desktop. I'm going to SSH into a different machine. I'm going to SSH into another Void Linux machine I have, one that I know is vulnerable. Photos is just the name of a machine that I have. It's my server that hosts my own photos, so I can back them up off my phone using Image, shout out Image. So this machine, we haven't actually run that Python script, so I just want to show you when you run SU before you run the script, this is what you would normally get. You would get a password prompt. You would have to know the root password before you log in. On this actual machine, I don't even have a root password set, so this just won't work. There is no valid way to log in through this. I'd have to use like sudo or something to escalate my privileges. So it normally does this. Once you run that Python script, then SU just suddenly starts working. So I wish I would have shown that first on Void, but just trust me that SU would have asked for a password. But now we can just get a root shell. Anyone logged into this machine can get a root shell. So again, not great. That's why I made sure to update my publicly facing servers. None of these are publicly facing. They're all on my own internal network. So anyone here could do this, but let's go ahead and patch them today. So like I said, I have multiple systems running Void Linux on my home network. They're all virtual machines. None of them are actually physical, so it's not a huge deal. But let's go ahead and verify that they actually have the vulnerability first, and then we can go through and we can upgrade them. So on my own system, I use my own configuration management that I haven't really talked about much, but take a look at this. Opt custom Etsy distro void. It's a mouthful, but here's a list of all the hosts that run Void Linux at my house. And these are all internal names, so they will resolve internally. So if you take like HAS, which is Home Assistant, and we were to run like, you know, host on HAS, or we get some errors here, but we get this. So this is the IP address for has.rapture.com 10.0.1.43, because 10.0.1.anything is my internal network on my home network. So here's all these machines. Technically speaking, we could log into each one of those machines one by one and upgrade them, and we may end up doing that, but for now, I can show you a cool way to test for this. So we can run SU here. If we run SU, we instantly get a root shell. Hey, that's pretty great, but wouldn't it be nice if we could run SU with some arguments? Well, here's the beautiful thing, you can. SU actually takes a couple different arguments, and one of them it takes is -c. So I can pass a command to -c with SU, SU -c, and then I can do like echo hi. Here's the problem. It doesn't work. It doesn't work because we've patched SU, and now SU doesn't behave the way that it's supposed to. It just gives us a shell no matter what. So that's not great, but we can still do something about this. We can pass in standard in. So we could echo a command and pipe that into SU. This might look confusing, but we are echoing the text ls into SU, and then it runs ls. So that's my home directory. We could echo whoami into SU. Also, because we're in bash, we could use here strings. So we could just do like, I don't know, ls dev, and there are all my dev devices. So you could pass it in that way, but basically we can echo whoami, pipe it into SU, and then we get root back. That's super great. If we were to run this on a machine with a working version of SU, one that isn't compromised, we will hang because it will ask for a password, and that's not great. So let me show that real quick. If we SSH back into photos, let's actually give it an S. If we echo whoami, and we pipe it into SU, still asks for a password. So even though like we're piping and everything, it still knows how to grab it. It does fail after some time. So at least it fails. That's really good. So we don't have to worry about like any sort of timeout. It seems like SU kind of imposes its own timeout. If we wanted to, we could also add our own timeout. Because we're on Linux, we will have the timeout command. The timeout command is super useful. You run timeout, 5 seconds, echo hi, and it will run the command, but it will optionally time out after 5 seconds have elapsed. So imagine if I were to run a command that would take too long, like, I don't know, let's say we want to sleep for 10 seconds. Well, 10 is greater than 5. In 5 seconds, the timeout command will cause it to fail, and it'll be a very specific error code. Look at that, error code 124. So timeout caused it to fail. So we could have used that, but it looks like SU does it for us. So let's go back to our broken machine. We're going to SSH right back into void. This is our broken machine, and let's figure out how to test for this. Because if we echo who am I, and we pipe it into SU, we're either going to get root or we're going to get a failure. And that is how we're going to determine which one is working. So remember that I showed you that list of all the hosts right here. So here's all the hosts on my machine running void. I have a tool that we can use to SSH into all of them at once and coalesce the data. Here's the tool I've talked about on my channel before. It's called SSHP. It's parallel SSH executor. It's something I wrote. It's a C program that I wrote. It's super useful. You can give it a list of hosts. There's a whole big README. I love documentation. You can give it a whole big list of hosts and it will go through and SSH into every one of them and optionally like coalesce the output or stream the output or buffer the output. I'll link it in the description, but I'll show you guys how to use it. I figure examples are more useful than actually just showing you the documentation. So let's do, instead of catting it, SSHP -f, the name of that file. This will be the last argument that we gave it. And then we can give it a command to run. Let's just echo hello. So now it will log into all those machines and it echoed hello and we get it here. So we get the name of the machine it logged into and hello. It's green because it was omitted to standard out, but we can see, hey, that's really great. What if we were to run something like uname? Okay, we can see that they're all Linux. I don't know why one failed to sign my key and then it worked that time. A little bit confusing. I think that has to do with the SSH agent on my Mac that I'm currently running. I'll have to look into that. It's a little bit odd. But here's the cool thing. So they all printed Linux because they're all running Linux. That's awesome. Here's a couple things we can do. The first thing is we can join the output together. -J will run all of it, coalesce the output, and then show which host had what output. So it finished with one unique result. All 9 hosts, and here's a list of the hosts, printed Linux. A little bit hard to read because of the .rapture.com being printed so many times. The nice thing is we can trim that off. We can also give it the -T argument for trim, and I'll trim off that part of the host names. So it'll say all 9 of these hosts printed the word Linux. That is super cool. That's super awesome to see. We could do something like echo hello, and then each one gives the same exact answer, hello. They might not all give the same answer. What if we were to print something that prints something different? Like if we were to run the hostname command, we should have, here we go, 9 different results. Again, this one failed. I'll have to look into that. That's super weird. But let's rerun that. There we go. 9 different results because sifs printed sifs.rapture.com, has printed has.rapture.com, and so on. So I love the -J arguments. It allows me to find outliers really quickly. And we're going to use that when we test for this. So instead of running hostname, we are going to run echo who am I, and pipe it into SU. Now, remember, SU should time out after 2 seconds. If it doesn't, well, that'll be some fun thing to debug in this video. But let's go ahead and run this and see what happens. Look at this. Okay, awesome. So as you can see, all 8 of these machines reported that SU was good. We were not able to hack SU. Of course, we weren't able to hack SU. We didn't run the Python script on them yet. But we weren't able to hack SU, but on void, we can, and we get root. So this is now how we will differentiate a vulnerable host from hosts that have actually been exploited. So we're going to use this. Now we have to go run the exploit across all of the machines. Well, if you remember, there was that nice little curl command. We could curl copy.fail/exp into that script. Let's go ahead and copy that into temp copyfail.py. We'll just put it in temp. That will get cleaned up when the VMs reboot. And let's go ahead and run that through SSHP. So here's what we're going to do. We're going to put the whole thing in a string. We're going to copy all of this. So this will go through, and on every single machine, it will run curl that thing and then write it out to temp copyfail.py. So every single machine that runs void at my house will have copyfail in temp once this runs successfully. We get a lot of standard errors because curl gave us that stupid little progress bar. So unfortunately, we really don't know if it was successful or not, but we can test it. So if we cat temp copy fail here, we can see that, hey, look, that's awesome. It was copied by temp directory. I don't think the server is going to be malicious, but let's go ahead and verify. Because we're on Linux, we have cat -v. I'm going to say let's cat minus V that file. Just look for any sort of hidden ANSI escape sequences that shouldn't be there. Like I said, this looks fine. This file looks exactly right to me. This looks fine. We're going to run this file across all our machines. Let's make sure that this file is exactly the same though across all the machines. We can do that in a couple different ways, but I figured the simplest is just to take an MD5 of copy fail locally, 458, whatever. Cool. And that's what we're going to compare everything against. So now we can rerun that SSHP command, get rid of all this, and we can just MD5 some temp copy fail.py. So this will go into all the machines and get the MD5. A little bit hard to read. They all look the same from here, but the nice thing is we have that -j argument, remember? So we should have one unique result. There we go. One unique result, this MD5 for that Python script. So that looks good. That looks safe to run. So let's go ahead and do just that. Let's run that across all of the machines. So we can get rid of MD5 here. We can get rid of -j, and we can just run Python 3 and then copy fail.py. I don't think we technically need the quotes here, but it's not going to hurt anything. So we're going to run this, and this is going to run it across all of them. Oh, interesting. It looks like some of the machines might not have Python 3. I didn't think about that before I made this video. Let's go ahead and test a machine real quick. What if we go into, let's go into photos again. We'll use you as our test. Oh, it doesn't have Python at all. That's so funny. All right, so I had to think about what to do here. We don't have Python on these machines. These machines are configured by a configuration management software that I use. I haven't really talked about on this channel, but it's something I wrote myself in Bash, of course, obviously. So what I'm going to do for the sake of this demo is I'm going to install Python across all these machines. And the nice thing is in the future, when I tear these machines down and recreate them, Python just won't be there because I like to minimize the amount of installed software on them. But for now, for the sake of this demo, I can go through all these and we can install Python in all these. So maybe that'll be fun to see. All right, so the first thing we have to do is some machines might need to reinstall XPPS to get it to the newest version before we can install new software because they're all going to be at different places. So this is void specific if you've never seen it. XPPS install -S to sync Y UV, and then we'll just give it XPPS. So this will tell it to reinstall itself. There we go. Now we should be good to go. They should all be in place to install new software. So we can XPPS install. We'll give it a Y for yes, and then we'll say Python 3. And I think that should work. This should go across all machines installing Python 3. If it's already there, nothing will happen. The beautiful thing is I actually run my own caching server for this. So the mirror for Void Linux is only being hit once, and that Python package will be downloaded exactly once to a local machine, and then everything will hit that cache. So even though I have a bunch of VMs hitting this, it's only going to be one making it outside. Okay, well, we have a failure, but the nice thing is we can kind of just test for it, and we can test for it. Let's see, what do you do? Python, if we do something like Python 3 -- version, okay, we could run that. So let's go ahead and run that across the fleet, and then we can quickly spot issues. Python 3 -- version. So one of these will fail, or they will all be successful. So there were some errors there, but they all installed Python 3. So I don't know, man. Good enough for me. So now that we have this, let's go ahead and run temp copy fail.py across all machines. It might not print anything because there's no output generated, but it works successfully. If we want to verify that, we could put a -e argument to SSHP, and it will print out the exit code. You can see they all exited with 0. So that is pretty good to know. Now we can go through and we can rerun that SU example. Let me remember what that command actually looked like. The SU example was this, I think. -t for trim, echo, whoami, pipe it into SU. So if we run this, we'll see what happens. Now they all print root. Okay, so what do we have here? We have, instead of one machine that has an SU that automatically pops a root shell, we now have 9 machines that all automatically pop a root shell. Hey, not great. I basically just went through and hacked all 9 machines, but we can verify that all 9 of them are susceptible to this attack. So to fix this, there's a couple different ways we can fix this, but I'm going to show you guys the easiest way. Your upstream package manager probably already has the fix in place. You just need to upgrade. I know this is a little bit anticlimactic, but this is how I would handle it as like a sysadmin over my own systems. We can just do an upgrade here. So that's what we're going to do. I can run, there's a couple different commands. I use a nice little wrapper for XPPS called VPM, Void Package Manager is what it stands for. So you can just run sudo VPM up, and it will update it, and then that'll handle everything for us. We could also do, I think, what did we do before? XPPS install -SVUY. We could do that. I'm double checking the man page to make sure I knew what was right. I think, I know what SY, what is U? Is U just update, I think? Okay, U is just update. Okay, I just wanted to double check and make sure I knew what I was talking about. So we could do that across the board. We could also just do it on a 1-by-1 basis. So if I were to upgrade void, it would look like this. XBPS install, capital S to synchronize with the remote server, Y to assume yes, U to update, V for verbose. We run this and it will upgrade every single package, including the Linux kernel. So that's what we can run here. And this will take a bit of time because as you can see, there's a whole bunch of stuff that needs to be upgraded. The nice thing is this is a recorded video, so I can just cut this part out of it. Now I'm only running this on one system just so we can kind of see it. I can reference this because with SSHP, it's going to do a lot of other stuff. But the beautiful thing is I could just open up a new terminal here. I could SSH into void. I could cat opt custom etc distro void. There we go. We don't want this host to run. So let's go ahead and grep -v for void. And there we go. Now it's been taken out of that list. And we can pipe this into SSHP because SSHP will read from standard in by default. So this will SSH into the other 8 machines and run the upgrade across them as long as I actually put that information in here. So let's do a sudo xbps install -syuv, and this will go through and update the rest of the 9 all at the same time. So there's going to be a lot of output that gets spewed to the screen here. So we'll let this run. There's a lot of stuff here, but we can reference this first page because, oh look, it's already updating Linux. That is so nice to see. So like I said, this will take a while. This will pull from the actual mirror and cache it locally, and these will all get hung when they get to Linux. They will suddenly stop processing and they will all look like they've stalled. That's because they're waiting for the cache to kick in there. So we'll just let this run. I'll let this run and I will come back when this is all done. Okay. It finished. It finished on void. It also finished over here, but I also didn't print the exit code, so one of them failed and I don't know which one. So that's super fun, but luckily we can figure it out by just seeing which one's still broken after we rebooted. I don't even know technically if this upgrade is going to fix it, but we're going to try that first before we go into like any sort of deeper measures here. This is how I'd approach this problem. So let's go here. Now what we have to do is we're going to reboot the machines, which will let them boot into the new kernel. Now, if you're curious, I did this on purpose in this order. I have this SSHP command over on this pane that filters out for ourselves. And the reason I do that is because I know eventually we're going to have to reboot the machine, right? We're going to have to run reboot. We'll run it with sudo. We're going to have to reboot the machine. I didn't want to get in a situation where this machine that is sending out all those SSH commands also reboots itself, because then we have a bit of a race condition here. So what we'll do is we'll reboot all of the other machines and then we'll reboot ourselves. So let's go ahead and we can run this. This should fail, I think, because they don't have, yeah, there we go. They don't have root privileges. So we'll put a sudo reboot here. This is very scary. Always double, triple, quadruple check your work. If you wanted to go through 1 by 1 and do this, I would not fault you. I think that's totally fine. For now, these are just VMs. If something goes wrong, I can log into the hypervisor and fix it. So let's reboot all these machines. Cool. Awesome. Let's go to the void machine over here and reboot. There we go. So we'll let these reboot. We'll let them come back and we will see if the issue is fixed. There's no real magic here. I'm just letting some time go by before I try to re-SSH back into them. So let's SSH back into void and see what happens. Okay. We have an uptime of 0 minutes. Okay, so it's just freshly rebooted. That's awesome. That's super cool. I guess we should figure out, is the vulnerability still there? So the simplest way, of course, is we can run su. If we get a root shell, it's still vulnerable. And if we get a password prompt, then we know it's not vulnerable. We haven't run the Python script yet, so we should get a password prompt no matter what. Okay, cool. That's correct. Let's go ahead and rerun that temp script that we have. Oh, we rebooted. Are they going to be gone? Oh, they're gone now because we rebooted. Ah, right. That's what I said would happen, and now I'm upset that it happened. Let's re-download that script real quick. I think we have a curl here. There we go. We can also, we had all those progress bars last time. We can do a curl -s, capital S. This will silence everything except errors. I find it very useful. And let's throw some things here like a -e so we can get the exit codes and figure out exactly like if they were successful or not. So let's run this. And there we go. They're all exiting 0. So that looks good to me. We did fail to log into WireGuard and SIF. So let's double check that those hosts actually came up. So SSH into SIFs. And it seems like something may have broke there. SSH into WireGuard. And seems like something broke there. So that's fun. Let's go debug that. I pulled up a different terminal here. So let's go ahead and log into the hypervisor, Datadyne. Let's do a z-ADM list. This will list all the zones that I have running, because again, all those void instances are virtual machines on the same host. No, they're not on the same host. Some of them might be on a different host. I'll have to double check that. What do we have? We have WireGuard and SIFs. So I believe SIFs is on this host and WireGuard is not. So okay, so we have SIFs here. It says it's running. Can we ping SIFs? We can't. So the networking is just not up, but it says it's running. So let's do the next step, which is z-ADM console into SIFs. Did we get anything here? I don't believe it's running. I have no idea what's going on. We're not getting anything on the console. I will tell you that it probably just failed to reboot, if I had to guess, so we can just kind of, was it restart? I think reboot or restart both work. Reboot SIF. So let's reboot it from the hypervisor's point of view. We might have to give it a forced reboot, but we can log into the other hypervisor, which has WireGuard. I forgot they're on different machines now. This is my router machine that virtualizes everything. So my DHCP zone, my NAT zone, my name server, and the WireGuard thing that everything logs into. z-ADM console WireGuard. Let's just double check. I'm not seeing anything on the console. So let's get out of the console and let's sudo z-ADM reboot WireGuard. So let's just give it a forceful reboot, and then we will see if anything has changed here. So let's try to ping WireGuard. That one might still be rebooting. Let's ping, what was the other one? SIFs? Still not coming up, so that's not great. Let's go into Datadyne. I'm willing to bet the reboot just needed to be forceful. That might be sending a signal to the operating system to reboot and it's ignoring it. So if we do a z-ADM list, we still get the same thing. If we console into SIFs, I'm going to assume it's the same thing. Yep, we're not getting anything here. I'm pressing enter. You can hear that's what's going on there. Nothing's happening. So let's break out of that. And let's do a sudo z-ADM power off SIFs. This is basically like we're pulling the plug on it. So if we do a z-ADM list grep for SIFs, we can see that it's still says it's running. We may have to forcefully power it off. I think we can do z-ADM list SIFs. Oh, cool. You can just do that. You don't have to actually grep. Okay, so let's figure out how to do a really brutal power off. I think it's -cap-f. I don't know. Is there a forceful power off? Forcefully stops the zone. Yeah, why would it still be running after a forceful one? That's really interesting to me. It'll probably shut down eventually. I bet if I keep trying, it'll be stopped. No, it's not. That's so weird. Let me do some debugging real quick. Let's log into the other machine. And just for completeness sake, z-ADM power off WireGuard. There we go. So we can z-ADM list WireGuard. And it still shows it as running. So I feel like something's just borked here. Luckily, there's still more we can do. Let's stop going through z-ADM. We can just use the underlying commands, zone admin -z, the name of the zone, WireGuard, and then we can give it halt. So we'll just skip through z-ADM, which is a wrapper on top of this stuff, and we will just give it this command ourselves and see what happens. This is really funny. I have monitoring through Nagios, and I have it send push notifications to my phone, so I'm actually getting alerts on my phone right now. WireGuard is down and SIFs is down. So they're down. We'll have to figure out what's going on here. This is really weird. I don't know why this would be happening, but there is still more we can do. Are you ready for this? We're going to really pull the plug. I know I keep saying that. pkill, normally you can give it the name of a process. I believe takes Z. Yeah, it does. Okay, we're going to do something gnarly here. pkill -9. So as you know, sig kill. It's like kill -9 -z WireGuard. We just have to sudo it. Okay. That should be what we need. It should be like unceremoniously brought down. Perfect. That's what we wanted. Something really must have got borked there. I don't know what's going on. z-ADM boot WireGuard. So now we'll let that boot up. We'll go to the other machine and we'll do the same thing for SIFs. Let's just double check. SIFs is still set to running. So something's really, really wrong. pkill -9 -z zifs or SIFs sudo run that. And if we do a list here, we are installed. Okay, cool. I don't know how that happened. I'm going to be totally real. I don't feel like debugging it right now. We're just going to power through this. z-ADM boot SIFs. Okay, now it's booting up. What state it'll be in, I have no idea. But let's get out of those and let's assume the networking is working. Let's assume everything's good by SSHing into WireGuard. We may have to do something else, but let's just try and SSH in the machine. It's not good. Ping WireGuard. Same thing. Host is still down. I don't know what's going on with these two machines. That's so weird. We'll have to debug these. Okay, that responded to a Z80M power off. This is super weird. Here's what we're gonna do. We're gonna try and boot it again, but boot takes a -C, so it'll put us right into the console as it's booting up. Okay, hey, so Void is booting up. Something's gonna be failing here. Out of memory. That's so interesting. Okay. Are they just too small? And then they go into a kernel panic. Interesting. Okay, okay. That gives us something to work with now. We're getting an out of memory warning. Let me do something real quick. Z80M list. Beehive at 2 gigs. Beehive at 512 megabytes. Maybe 512 megabytes just isn't big enough? How big is this machine? Omni fetch. This machine has 16 gigs of RAM. Okay, yeah, and this one's using 512, 2, 512. These could be so much bigger. Okay. Maybe just having a Beehive that's 512 is not big enough. We might have to bump it up to 1 gigabyte. So I bet if we go over here, do you think the SIF zone is going to be the only one that is that small? There's a couple mixture of Beehive and LI package and I package here. Let's do brand equals Beehive. And this will just give us the Beehive zones. I don't remember the syntax off of this. Let's just grep for Beehive. It's easier. There we go. Look at this. This one's 512. I just wonder if it's not enough memory. That really could be it. That could totally be the problem here. All right. How about we go edit these two things? It's unfortunate they're on different machines. Z80M, edit, SIFs, and let's change it from 512 to 1 gig. So 512 megabytes, let's just make that 1024. And then there should be another place where it's physical. Yeah, here we go. 1024. So there's 2 different places where the memory is set. The reason for that is the way this works is we create a zone, an Illumos zone, like a Solaris zone. Have you ever seen those? And then the Beehive instance is created in that. So you can set those technically to be different, I believe. We're just going to set those to the same. We're going to set those both to be 1024. So now we can do a Z80M power off SIFs. And when we power it back on, it should have those new settings. So let's go ahead and just verify that it's powered off. Okay, it's powered off. It's all the way at the bottom. Boot -C SIFs, which will give us the console. So we should get the grub page for Void. There we go. And okay, there we go. There's some Void Linux debugging for you guys. Now it works. Now we have a console. That's great. So _dot is my escape hatch out of there. Now we have the SIFs zone running. How nice is that? Let's go into here. Sudo Z80M edit. Wow. Hopefully this was fun debugging live. Hopefully you guys enjoy this. Z80M edit WireGuard. The fun part is I didn't plan this at all. I would have loved to have said that I planned this so we'd have like a fun video. This is just like totally genuine. I just actually had to debug this, and yeah, so hopefully this is fun for you guys. We're swapping 512 for 1024. That's awesome. Sudo Z80M power off WireGuard. Sudo Z80M list WireGuard. And we can see that's installed. That's awesome. Sudo Z80M boot -C WireGuard. And then we should get the console again. We'll go ahead and hit enter, even though that'll just be the default. And no suitable video mode for... Oh, wait, hold on. But that might be okay. That might be okay. There was no suitable video mode format found. That's fine. There's no like... This is a serial console that we're looking at. We're not actually looking at like a VGA. So, okay. We might be good. Let's go back to this first terminal that we had open. Let's ping SIFs. That looks promising. Let's ping WireGuard. That looks promising. Let's SSH into SIFs. That looks promising. There we go. And let's SSH into WireGuard. Awesome. There we go. Beautiful. Let's try and figure out where we were before the break. Because I have to remember what we were doing. We were curling everything, I think. I think that's the last thing we were doing, is we were curling the proof of concept exploit over to temp copy fail, and it failed on WireGuard and SIF. So if we run this, it should work out. Okay, perfect. It worked everywhere across the board. Let's go ahead and let's vim our local copy now of copy fail just to make sure. That looks good to me. I wanted to make sure there's no nonsense. Actually, we can get rid of the call to system there. I guess it technically doesn't matter, does it? Did we get rid of it last time? We didn't, and it still worked. So I guess let's just assume it works. That's totally cool. Awesome. Leave that in there. We can MD5. So this MD5 sum is going to be similar to what we saw before. Awesome. So let's go ahead and find the MD5 where we ran it across all the machines. So we're going to MD5 all the machines. They all have the same result, so they all have the same script there. That's awesome. Let's go ahead and run that script across all the machines. So I think This is it. SSHP into that file, -E Python 3, -E shows the exit codes, and then it'll run that script. So we'll run this across all of the machines and we will see what happens. Okay, well, we failed on a couple of them. Interesting. Let's go ahead and just rerun it just to make sure. And we are getting this SU error there. This might be good that we're seeing this. This might mean that it worked. But let's go ahead and run the last thing that we know works. Because if we ran it locally, again, we can run this as many times as we want. It's not going to cause an issue. If we run this, look, it's still asking for a password. I think it's fixed. I think it's actually fixed. Echo, well, reset the terminal because apparently the terminal got messed up. Echo, whoami? Pipe it into SU. It's fixed. It's fixed on this machine. That is huge. That's amazing. So if we grep for echo whoami, I think if we search backwards, there we go. This was the command we ran, which will run it across all the machines, and we will see if there's any failures or what's going on here. So very, very interesting here. Look at this. So Hass gave us a public signing key. I gotta look into this. It's something about my local agent that doesn't really like it. It looks like Notch, which is my Minecraft server that hasn't actually ran in like years. It's not even enabled. This one looks like it still gave an issue. So this probably failed to update. We can go look for that. Hass also gave us a signing error. I bet if we run it again, the Hass error will go away. I think it's just intermittent. So let's go ahead and run it. The fact there's two there now leads me to believe we'll probably get an error. Hass and Notch both give root. Okay, interesting. So the Home Assistant virtual machine and the Notch virtual machine still give us root. But this is, I hope you guys enjoy this. This is kind of like the actual approach I would take when I'm managing these systems, how I would go through and fix them all. Obviously, if you had some sort of like, you know, static configuration, if you had, what's the word I'm looking for, immutable style systems, and you didn't like to actually log in and manage yourself, you could just, you know, set up whatever kernel version you want. But I'm just managing these very simply, and if you were in my boat, this is how you'd have to fix them. So let's go ahead and hand fix both of these now. Also, if you like what you see, go ahead and hit the subscribe button, okay? It's free. What are you doing? Just hit that subscribe button. We already hit 100,000 subscribers on this channel, but we're going for 200 now, okay? So go ahead and hit the subscribe button. Let's log into these machines and see what's going on. The Home Assistant zone. What's our uptime on this? Let's make sure it actually rebooted. Okay, it actually rebooted. If we run su, we get a root prompt. That is not good. We don't want that. So let's figure out what went wrong here. xbps install -svu, and this will do the full install. I'm willing to bet that something broke here. And we will see what happens. Yeah, the fact that all this stuff shows up means that something broke, something borked, something went wrong. Because I'm willing to bet we'll see Linux here. Yeah, Linux 6.12, 6.6, Linux based. Yeah, so it needs to update this. It just failed the updating process. Remember when I showed when the updates finished, there still were some failures? We'll have to go through and figure out what those are. So that's Hass. Let's go over here to the other machine that failed. Notch, and I'm willing to bet it's the same thing. xbps install -cap syvu. There we go. Run this. Yeah, look how much crap is here. So it just failed to upgrade. It's not a big deal. We'll just run the upgrade. All the files will have been downloaded and cached. If there was any files changed in between the 20 minutes that the update take, I'll have to pull them. But like, look, it's going so fast. It's not going to have a problem. It's probably failing somewhere during the install. So I will just have to page back and forth. I'll let these run and we will figure out kind of what's going on. So again, I may have to cut the video here, but when I come back in, we'll see exactly what's going on. Okay, well, the Home Assistant zone just worked. So there was probably some sort of intermittent failure. I don't know, maybe a network issue. Who knows? But you just run it again and it works. It's so beautiful that a lot of these commands are idempotent because I rely on that. Let's check on the other one. All right, Notch is still working over here, but the Home Assistant one seems like it's working. So we can go ahead and give this one a reboot in the meantime. We'll let this one go down for a reboot and we'll test it again. Oh, that also means it's going to be cleared out of temp. Maybe I shouldn't have stored it in temp now. Storing the file in temp was optimistic, and I think at a certain point to be a sysadmin, you got to have some optimism. I mean, come on. All right, Notch worked just fine too. So let's go ahead and give that bad boy a reboot. And we are back on the Void machine, and we will wait for those machines to come up. So we've SSH to Hass. I assume it's still up, or it is up. It is up. Cool. It's been up for 0 minutes. That's great. And if we SSH into Notch, we'll see, it's probably in the process of coming up, probably bring up the network interfaces now. Cool, I don't know why I'm getting that. Uptime, up 0 minutes. Hey, look, that's awesome. So let's go ahead and rerun some commands. So let's curl that script again. So this will curl it to all the machines. Awesome. Then we will go through, we'll MD5 it just to make sure it's sane. I just like to make sure if we're going to run it that it's sane. That MD5 looks like what I saw before. I'll verify my local copy. Cool, so they all look like this. Great, awesome. And the final step is to run it. So Python 3, copy fail, run it like this. And the final step is to test SU. So I think we just did, what do we do? Echo, whoami, SU, and that. There we go. So let's run this across all the machines and let's see what actually happens. One finished really fast. That does scare me. Oh, it was a permission denied into Home Assistant. Yeah, I don't... This is on my to-do list to fix. On my Mac, I use a program called Secretive, which allows me to store my SSH key in the like secret enclave that the Mac has. So it's like a hardware SSH key, but without a USB dongle. That's what I'm currently using. So there must be some weirdness with that. I don't know. I'm not going to throw it. Like there could be some. I'll have to test this. I'll do some debugging, maybe see if there's any open issues. And maybe it's not secretive. That's what I currently use. So I'll have to dig into that because that's super weird. But if I rerun this, is there a chance it'll work? No, see, that one finishes right away. It must not like SSHing into Home Assistant for some reason. Nope, now it's Vultr this time. Dude, that's so weird. Something's wrong with my SSH agent. I don't know, but maybe there's some race condition and we'll win this time. Hey, look at this. SU, authentication failure. That's amazing. We can spot check some of these machines. This is what I would do like if I was working somewhere and managing these systems. SSH into HAS, run the same thing again, and then run. Oh, look at that. Cool. So it fails. Good. Awesome. So there we go. We're fixed. That fixed the issue. So I logged into all the Void Linux machines. I also tested my Magic Mirror. Like I said, it was not susceptible. I tested my remote web server. It was not susceptible. So we're good there. I don't have any other Linux machines running here. I don't have any Linux physical machines, and it's all running on virtual machines. I guess that's technically a physical machine. So yeah, I think that's all that needs to be done. So yeah, I guess let me know what you guys think about this style content. Let me know if you enjoy this, because this was interesting. I had just planned on fixing these issues myself and logging in and doing this, and it's like, it's not a big deal, because I've been doing this for so long. Sysadmin's just like, second nature to me. Like, it's fun. Don't get me wrong. I love it. It's fun. But normally I share like programming content. Obviously the name of the channel is You Suck at Programming. Let me know if you guys like this style of content where I kind of give you some inside look at the servers I'm running or what kind of like things are going on or how I manage the updates across them, because a lot of it's more manual than you may realize, but a lot of it's like still, I have a lot of cool tooling I've built around it. You might look at this and be like, Dave, this is super old school. We have way better ways of doing that. That's fine. I think this stuff is fun. I like running servers because they're fun. So yeah, let me know if you guys enjoy this style of content. I thought it was super interesting. Yeah, it's super fun for me just to kind of like give a tour of this stuff. Let me know what you guys want to see. Thank you so much for subscribing. 100,000 subscribers. That's crazy. I can't believe I actually hit that. 200 is next, and I can't wait to hit that milestone. It's going to be a ton of fun. And of course, I can't leave you guys without this. Check this out. You ready for this? This is very, very exciting. Legit, I'm not even lying. This is very exciting. Look at the overflow here. Look how many people have signed up to my Patreon. Shout out to my patrons over at Patreon. I'm going to do something a little bit gnarly for this video. Let's resize this. I don't want to get anything too cut off. We're just going to resize the terminal. And I'm going to stare at my OBS, and hopefully I can do this. There we go. Awesome. I don't want to get anyone's name cut off. But take a look at this. Thank you, everyone who signed up for my Patreon. We have 113 active members. That's crazy. The names are going off the page. I'll try and make them as big as they possibly can be. Sign up for my Patreon if you want to get your name at the end of my video like this. Thank you so much, everyone, for your continued support. Of course, now that I'm unemployed, I need as much money as I can get from you guys. No, really, like I said before, don't feel like you have to donate to me. It's totally cool if you don't want to. My content's going to be free, and you can watch it, and just subscribing is more than enough. So thank you so much for my patrons over at Patreon. You guys are awesome. I'm going to have to go live soon, and we will work on this tool that prints this out, because I think what I want to do is make like a little TUI that scrolls them, like credits. So it'll start from the top and scroll them. Maybe only have 2 or 3 columns for the name, and it will be like credits rolling, but it will all work on the terminal. So I'll probably go live. We can work on that together. I think that'll be a ton of fun. No promise as to when that happens. But yeah, thank you so much for watching, guys. You guys are awesome. That's all I got. See ya.